What's up, smart people? Welcome back to the channel. So tomorrow is actually your physics paper 4 paper. So I thought of doing a final push before your paper tomorrow. Basically today we'll be looking at all the things that you should know, the basic things you should know so that you avoid these mistakes during your exam and you can answer it properly. So it's a very small thing, don't worry. It's a very calm video, just chill, okay, throughout this video. It's just a few skills that I would like to share to you. Some of these I have made the mistakes myself, and some of it I saw from the examiner reports. So let's see what we have got today. Right, so the first line, here they said, candidates should be advised not to rely heavily on memorizing previous mark schemes. So if you are someone who particularly memorize mark schemes for the sake of it, please do not do that. It's not too late to stop. Actually, stop doing that, because when they ask a similar question but twist a bit, you might not be able to answer it if you blindly memorize the answer scheme. So it's really important to understand what the question is asking and make sure to read the entire question fully. Don't read halfway and straight away go and start solving. Make sure you read it fully, and if you don't understand, read it once again slowly. Okay, so first thing, ratio. Your ratio must always be in decimal. If they ask you to find ratio, make sure it's in decimal, and of course minimum to 2 significant figure. You can go up to 3 significant figure as well, but minimum is 2. And no fractions at all. Even though it's like a perfect fraction, like it's 1/4, a very nice looking fraction, don't write it as 1/4, write it as 0.25. Even though your fraction is correct, you write 1/4, you'll get it wrong. They're not going to give you any mark because they're expecting a decimal value. Okay, second one, rounding too early or misusing significant figure. So here's the thing, you only round to 2 significant figure for your final answer. In between calculation, make sure you use more than 2 significant figure for accuracy. Or in other words, you can use 4 to 5 decimal places to ensure your final answer don't run away too much. Then your calculation should reflect the precision of the data given. In other words, like I said, always give your answer to at least 2 significant figure unless told otherwise. If the question explicitly say to 4 decimal place, make sure you give to 4 decimal place. Don't give to 2 significant figure. Follow what the question said. If they did not say anything, then as usual, you can give to 2 significant figures. So like I said, read the question properly. Underline the keywords. You can't bring highlighters, so just underline or circle. It's your paper. As long as it doesn't disrupt your answer space, of course, right? Yeah. Third one, make sure to convert grams to kilograms. This one, if you have done a lot of past years, I think by now you are so used to it, how to convert grams to kilograms. Basically, you times 10 to the power of negative 3. And another common thing that you might do is you use mass instead of weight. Let's say you want to find the weight, or you want to find the force, usually not weight, you want to find the force of an object, let's say in moments. You might accidentally just take the mass and straight away calculating it. You did not take the weight. So remember, make sure you take the weight. Weight is W equals to mg. Don't accidentally take the mass. So I say do the question slowly. Doing it fast is one, but doing it with precision is a skill you need. So see what the question is asking properly. Is it mass, or did they give you the weight? If it's not mass, make sure you find the weight. Okay. Then, of course, likewise, be careful with metric prefixes. This one is also important in paper 1 as well as final answers in paper 2 and 4. So usually in your final answers, right, usually they'll give you a line, then they'll put here meter. If let's say you want to find the distance, they'll put here meter. Sometimes they put nm. Nm is nanometer. So if let's say your answer you get 6.9 times 10 to the power of negative 9, if your final answer, the given one, was written as nanometer, make sure your answer is 6.9, only nanometer, because they already give you the prefix there in nanometer, and this is actually nano, 10 to the power of negative 9. So you just write 6.9. If it's meter, then you write 6.9 times 10 to the power of negative 9. So in order to know the prefixes well, make sure you remember what is mega, what is tera, what is giga, because recently they've been asking a lot of like picometer, micrometer, all this they ask instead of just writing meter. So be aware in paper 2 or paper 4. So you'll be aware. Okay, so look at your final answer. If the units are given, make sure you answer accordingly. Another thing to point out is this one can also happen in paper 1. So if you see, I've written here power of 10 errors. So what do I mean by power of 10 errors? So for example, after calculating your values, let's say in paper 1, your answer you get as 3.6 times 10 to the power of negative 3. Okay, but in the multiple choice answer scheme, probably A, it says 3.69 times 10 to the power of negative 5. Then you have 3.6 times 10 to the power of negative 2. So this is what I mean by the wrong answer will have the correct value but the wrong power of 10. If you realize here, they have the correct value. The B has the correct value, but the prefixes here is different. This is negative 3, this is negative 2. So don't just stop looking at the answer at the first, 3.6, okay, this is the answer. No. Look at the entire thing and especially track your prefixes really well. So that is why it's very important to know your prefixes value. All of them. Not only for paper 1, paper 2, paper 4 also. I think it's also important for 3 and 5 lah. Prefixes is basically the basic thing you should know in calculation. Okay, then we also have some examiner's report here. They want you to know that when answering numerical question, basically calculation question, it's a good idea to try to calculate the answer before looking at the answer option. Basically, try to work out the problem yourself first before looking at the answer, because they don't want you to guess. Don't guess the answer. First work it out, then look at the answer. Candidates need to ensure that the units used in the calculation are consistent, particularly if the information includes prefixes such as this, or data which includes area in millimeter square or cm square, or volumes. Basically what they're trying to say is, if this type of area is given and you need to use that value, make sure you convert it to meter square. So always read the question properly and check the units. And it's very normal for Cambridge to put all types of units. They probably give you nanometer out of nowhere, terameter out of nowhere. Make sure you know how to convert. Okay. Next, you must write the correct unit for the final answer if it isn't provided. So like just now I said, sometime in the final answer they'll give you nanometer, or sometimes they just give you meter. So if they already give you, you just write your value in your answer. This is for paper 2 and paper 4. But if they did not give you, you make sure you write the SI unit for it. Just write the SI unit form. That would be safer. Make sure you write. Okay. Then 6. For calculation question that requires you to answer, to answer from the previous part, copy properly. Like actually copy it properly. Don't write so fast and you saw the number wrongly. Instead of 6, you're going to write 9. Instead of 6, you're going to write 5 or something. It's going to ruin the entire thing. But thing is, if let's say you accidentally copied wrongly, of course you will not realize it during exam. If you realize it, that's really good. If you didn't realize it, and even your answers from your previous question is wrong, if it's wrong, and you use it for this particular question, which caused your answer to be wrong also, because your previous question answer is wrong, and you use that value back for the next question, so definitely your answer will also be wrong for that, right? But thing is, good news is you'll still get full marks as long as your calculation method is correct. This is something called error carry forward lah. So even though your first answer is wrong, but you use that value and your calculation method is correct, you will get your full marks still, because it's something called error carry forward. So what I'm trying to say here is, don't leave your paper empty. Always write something in your paper, because you never know which part of a method you will get marks. Okay. Then we have the next one. Prove, show, derive for any similar synonyms. When you see this particular question, when they ask you to prove, show or derive or anything similar to it, marks are allocated for workings. So it is extremely crucial to show complete workings on how you derive it or how you prove it completely. Don't skip any steps. These are free marks, because they already tell you to derive this equation. Make sure you derive it completely and explain it if it's necessary. Sometimes in the question they'll ask to explain, so explain it. Or if you think, even though they didn't ask, you think, oh, there's a need for you to explain it, write something there if it's necessary. But make sure it's complete working. Don't skip any step, especially when it comes to proving, showing or deriving. Because all this answer is given in the question. So they expect you to be very explicit with your working. Okay. Then, this is very, very important, honestly speaking. It's like something really you should know. Write down the formula before substituting values, because you will actually get marks for writing the formula, and given the fact it is the correct formula for the question, not a wrong formula. Okay, make sure it's a right formula for the question. And clear steps can earn marks even if the final answer is wrong. Avoid doing too much in your head. Roughly do calculation on the question paper. Just write all your calculation in the question paper, because you never know where you can get marks. And here is also another thing examiner wants you to know. Candidates should always be encouraged to think about the magnitude of the answer they arrive at. That means your final answer. For example, the radius of the orbit of a satellite cannot be a few meters. So if you calculate the radius of the orbit of a satellite and you get a few meters, logically speaking, something is not right? So look back at your working. And another thing is the number of protons. Another example is number of photons arriving per unit time on a metal surface cannot be, of course, times 10 to the power of negative 17. It's a bit insane, right? Shouldn't be times 10 to the power of negative 17. It's a number of photons. So when you get your final answer, take a few seconds to think, does this make sense? If it makes sense, move on. If it doesn't, that means something is not right in your working. So look back at it. It's usually some small plus minus thing that you might have done wrongly. Okay. Then Newton's third law. Okay, this one is not a very major thing, but it can be a very big misconception at times. Newton's third law acts on different bodies. So imagine a book resting on a table. The book pushes down on the table, which is the action, with force equal to its weight. Then what happens is the table will push up on the book, which is reaction, with an equal and opposite force. So pushes down is the downward force from the book, and upward force is from the table. So realize it's acting on the two different bodies. They don't act on the same body. So knowing this will help you to eliminate some answers in paper 1 especially. In paper 2, at the max, you probably need to explain it lah. Yeah. Then 10. Know the difference between the area of square or rectangle and the area of triangle. Seriously, there's a reason why I wrote seriously there. Especially Hooke's law, Fx asks you to find the area. I know you might be laughing now, you'll be thinking, it's really triangle. Why would someone, go and find area of square? In exam, you will never know. You just straight away take length times base. Then you straight away get the area. You just take length. Or in this case, if it's the triangle, you just take length, you just take the height. You forget to times half, because you are thinking this is a square. This happens when you do really fast. You're trying to finish the paper fast in exam. So, be aware. triangle, make sure you half it. 1/2 times base times height. This one is usually happen in Hooke's law question usually. So be aware of what shape the question is showing to you. Okay. Oh, also another thing to point out. I think I did not write it here. Wait, let me check. Oh, okay, I actually wrote it. Okay, never mind. We'll go to that later. I wrote it somewhere below. Okay. Then in parallel spring, total energy is equals to sum of energy stored in each spring. So this one, right? If let's say you have a series spring like this, so it's a reflex action that you take both energy and you add because they are in the series. Just add them together. But sometimes, right, not all the time, when you have a parallel spring, you might accidentally just take one energy and you get the answer. And if this is paper 1, Cambridge would purposely do that. They'll put energy of one spring as A and probably the sum of energy stored in spring as B. So the moment you get the first answer, you think, oh, the answer is A and tick. But it's not. The total energy, if they have to find total, is sum of energy stored in each spring. Take this one, make sure you plus. Don't forget to plus it. And then we have flip graph axis. So this is actually very important when you're calculating gradient, for example. So check your graph before calculating the gradient, whether is it f against x or x against f. And this one might also happen to IV graph, current against voltage graph. So look at your axis properly. Whenever they ask to find gradient, look at the axis, whether is it what they want or do you need to inverse it. Yeah. Then next one we have drawing graph. So you must be able to sketch graph of common simple expression as far as y equals to kx square in exam. That means you must know how to draw at least a quadratic graph in your exam. So for example, energy versus extensions graph for a spring is a quadratic. Why? Because this is the formula for energy for a spring. Right. So looking at this, we know that therefore energy versus extension would be a parabolic graph, not a linear graph because of the square. So if they ask you to draw a graph, always look at the equation. Always derive what the graph should look like from the equation. It will actually help you to draw your graph easier. And when sketching, label the axis with units. Don't forget your units and the key points, like example your intercepts or limits or maybe your lines. You need to label it. If your graph has more than 2 lines, example, usually this one is energy graph for simple harmonic motion. This is energy, this is displacement. You have this and you have this. So you have 2 graphs. Make sure you label what is one graph. This is KE, of course, and this is PE, potential. So make sure you label them. And then the next one, 14. In diffraction question, don't forget the central fringe. The total number of maxima is 2n plus 1 for n on each side. So this is quite a common thing that you might overlook because especially in paper 1 and paper 2 also. So when they ask for a number of maxima, you have to find the number of orders n based on your formula, then multiply by 2 and add 1. Multiply by 2 because when your n number of orders is only on one side, say this is your n equals to 0, central order, you only find at one side. But if they ask you for number of maxima, you must times by 2 because you need to know what is this side also. So total. So that's why you must times by 2. Then add by 1. Why add 1? Because of the central. Central order, you have to add by 1. So you have to consider both sides when they ask for number of maxima, not only one side. Then draw your waveform correctly. Okay. Remember, node is 0 displacement. Antinode is maximum displacement. Node is a very small thing, but it will be really important for you to know, especially when you draw in exam, when they ask you to draw node or antinode. This is the one I wanted to say just now. You must be able to recall the volume of spheres or cylinders. This one is actually a requirement. Sometimes they ask you to find the volume, they ask you to find the volume of spheres, cylinders, so you make sure you know your formulas really well. Then, always check if the problem asks for a vector, velocity or a speed. Both of these makes a difference. It defines whether you need displacement or distance. Then in collision and momentum, keep track of the direction. Do not drop the sign when the spheres rebound. Make sure you set whether your right should be positive or left should be negative. Your signs is really important and it can make a difference in your final answers. Okay, 18. Don't drop the negative when calculating gravitational potential or gravitational potential energy, because in the formula itself the negative is there. Don't drop it, because at infinity GPE is 0. So coming nearing to the earth, you're going to get a negative potential. So do not ignore the negative. Very important. Last one. Equilibrium doesn't mean object must be stationary. This is a very, very huge misconception. Equilibrium means confirm stationary. No. Equilibrium means the net force acting on the object is 0. The resultant force is 0. That means the forces are balanced. So don't assume that it is stationary. Alright, so that's about it for today's video. I hope this gives you a bit of an insight on what you should know in case you forget certain things, so that tomorrow you'll be more aware, during your paper. So I wish you all the best, really all the best. You've came this far, so I think no worries, you're going to do really well for your paper tomorrow. Just remember to stay calm, drink your water, make sure your calculators is working, okay, and bring 2 calculators if you have. Make sure they are working as well. And also remember to read the question fully. Don't stop halfway, read fully and understand what they're trying to ask. So the moment you get a paper, first flip through the entire paper. Look at all the question and start with the question that you are most confident in. Because when you start with the question that you're most confident in, for example, your favorite chapter or what, you will actually get better. You will feel better throughout the paper because you started strong with the paper. So flip through the entire paper, start with the question or the chapter that you're really good at or you're most confident in, then slowly move on to the rest. And trust me, I think the A star is within your reach. So thank you for being with me throughout the journey and I wish you all the best. Goodbye and take care of yourself, okay?